Hello, Addi and Jadah. Here is your lesson for the class that we missed. I am so sorry that my car broke down and I couldn't make it for class. I didn't actually make it for grants either. We were just stranded until you fixed it. We were losing water. It was a whole lot of stuff. But car is fixed. Made it home. Had a little bit of a crazy weekend, but I'm putting the video up for you so you have it until Wednesday. Any questions that don't make sense, we'll deal in the class on Wednesday, okay? We are on 11.1 angle measures in polygons. Today's lesson, the one that we're doing video, not hard. This is why I thought it was going to be okay to do it on video, because I know it's not going to be okay. Okay, so if you remember, here's a little quick review. We have talked a few chapters ago that the sum of angles in a triangle is 180 degrees. So I know for a fact that in a triangle, I get 180 degrees. So this angle plus this angle plus this angle together are 180. In a quadrilateral, you might remember, it's a possibility that you remember that the sum of all the angles are 360. But if you don't remember that, if I just draw one diagonal, I now have two different triangles. Again, in one triangle, I have 180. For this one, I can do 180 times two triangles that I have, 360, right? If I move into a pentagon, and I go, well, I don't really know the sum of angles in a pentagon. If I just go ahead and draw the two diagonals from one vertex, and I can split it in three triangles, then I get 180 from one triangle times three triangles that I have, and this gives me 540. It works the exact same way with a hexagon. If I don't know what it is, all I have to do is draw from one vertex all of possible diagonals. I get four different triangles. This becomes 180 times 4, or 720. Which really brings us to the formula for the sum of angles in any polygon. So this one, we just use 4. We went from 3 sides to 6 sides. But what if I tell you what's the sum of angles in a dodecadon? That's 12 sides. Well, you wouldn't know. You would have to do all the diagonals. You don't have to do that. This will teach you a formula. If you think of a triangle, I'm going to do this times 1 because it's one triangle. How many sides does it have? 1, 2, 3. But I'm timesing it by 1. Let's look at a quadrilateral. 1, 2, 3, 4. But I'm timesing it by 2. So this means in here I minus 2. In here I minus 2. In a pentagon, 1, 2, 3, 4, 5. What do I times it by? 3. I'm minusing 2. Let's look in the hexagon. 1, 2, 3, 4, 5, 6. But I'm timing by 4. Again, I'm minusing 2. Which brings us to the formula for the sum of angles in any polygon. It's going to be the number of sides, n, minus 2. Do you see the pattern? Times 180. That is the formula for the sum of angles in any polygon. If you are with me in the book, we're on page 662. We're going to deal with example 1. We're going to break this in 3 different things. Example 1 says, find the value of x in the diagram shown. Well, if you notice, that is a hexagon. So I already know the sum of angles is n minus 2 times 180, or 6 minus 2 times 180, which gives me 4 times 180, which is 720. So I know the sum of angles in that particular polygon, it's a hexagon, it's going to be 720 degrees. I have 5 of the 6 angles. There's many ways to do this. The book adds them all up and then minus them from 720 to get the answer. The fastest way for me would be to go 720 minus 136 minus 136 minus 88, not plus, minus 142 minus 105. Oh, I missed one. Oh, minus 100. 200, and I missed one. What did I miss? Oh, 113 is the missing thing. Really, I went 720 minus 136 minus 136 minus 88 minus 42, and minus 105. That leaves me with x, which is 113, right? I know 5 of them. I know the total sum. All I have to do is subtract what I know to get to what I am missing. The second formula from this particular subchapter We're still on page 662. We just dealt with theorem 1.1. Let me erase everything else from here because I don't need them. Is when we're dealing with a regular polygon. So this is just some of angles in any kind of polygon. When we deal with a regular polygon, then let's do a quick review of what a regular polygon is. I just went blurry, now I'm back. A regular polygon has all of its sides congruent, all of its angles congruent. So if I have all of the angles congruent, that means if I just need to find the value of one angle, the measurement of one angle in that regular polygon, it's going to be the sum of all the angles, n minus 2 times 180, all of the angles together, divided by how many angles I have, n, right? So let's look at example 2 because it's going to make more sense. It says the measure of each interior regular polygon is 140. So the measurement of every angle in a regular polygon is 140 degrees. How many sides does the polygon have? We're looking for n. If I know that each angle in this regular polygon is 140, how many sides or how many angles do I have? So let's use that formula. The measurement of any angle in a regular polygon, or 140, will equal, and I'm going to put it over 1 just because on this side I'm going to have a formula, n minus 2 times 180 divided by n. All I need to do is solve for n. I'm looking for how many sides or how many angles. So cross multiplication to the rescue. I get n minus 2 times 180 equals 140n. Here what I get, I had 180 n minus 360 equals 140 n. I minus 180 n on the other side. Negative 360 degrees, or just 360, equals negative 40, and I divide the negative 40 out, and equals 9. The polygon has 9 sides. How did I get here? Very easy. I knew the measurement, I knew the formula, I knew the measurement, I needed to know n. Okay? So let's look at a separate problem in the exact same way so we know what we're doing. Here's another type of problem. Find the measurement of each angle if we have a regular 11gon. That's not the name of it, but I don't know what it is. I don't know how you call it, 11-side pentagon. 11gon it is. What is the measure of each particular angle if this is a regular polygon? Well, the measure of each angle is going to be n, 11, minus 2 times 180 divided by how many angles do I have? 11. This becomes 9 times 180 divided by 11. This is seriously a absolutely calculator problem. 9 times 180 equals divided by 11. It's going to be a decimal. It's not a big deal. This becomes 147.3 degrees. So if they tell you it's a regular and tell you the sides, all you have to do is replace n with how many sides you have, and you find the measurement of each angle. This is the first part of formulas that we have from 11.1. We're going to move on to 11.1 part 2, or I guess it's called the second goal. Let's look at what we call outside or external angles. Every polygon that you will have, if you prolong one of its sides in the exact same direction, you're going to end up with the exact same amount of external angles. So this is a pentagon. I have 5 interior angles. I'm also going to have 5 exterior angles. How did I do this? On each side in the same direction, I just went ahead and prolonged that side. And now we're going to talk how much is the sum of the exterior angles on any polygon. This does not apply just to the pentagon. On any polygon, that sum is going to be 360 all the time. So here's what we know. Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, it's going to be 360. If I would have had a octagon, angle 1 plus 2 plus 3 plus 4 plus all the way to 8, these are the exterior angles, all together will equal 360 without any doubt. On the same time, if we're talking about a regular polygon, then if I want to find out the measurement of one single exterior angle in a regular polygon, that measurement of that angle is going to be 360 divided by how many angles or how many sides we have. In case you get confused why I'm just casually using sides of angles, is because when we talk about a regular polygon, for example, a regular hexagon has 6 sides, 6 angles. A regular octagon, 8 sides, 8 angles. So it's the same amount of angles or sides. That's why I say n can represent angles, n can represent sides. It will be the exact same thing. Let's look at example 3, and we'll do A and B together. The rules are on the board. Here's what it says. Find the value x in each diagram. We're going to stay with A. We have all of those, 1, 2, 3, 4, 5 external angles. And I need to find out what x is. Well, here's what I do know. The sum of all exterior angles together is 360. So I go x plus 2x plus 2x plus 4x and plus 3x. These two equals 360. Why? Because that's what my theorem says. The sum of all exterior angles is 360. 4, 8, 12. 12x equals 360. X equals 30. So x is 30. Great news is they just want you to find x in this particular problem. You don't need to know what each angle is, just what x is. So all we had to do is add all of the external angles, equal them to 360, make the division, and get x out. Let's look at B. The first thing that I want you to notice in B is that it's absolutely a regular polygon. How do I know that? It has a sign everywhere for each side, same marking. For each angle, same marking. So I know that is one regular polygon. You lost me. I'm coming right back. Just let me. Hello. Come on. Let's focus. Here you go. Here we go. So here's what I do know. I know that x, it's going to have to be 360 because this is a regular polygon, divided by how many sides do I have? 1, 2, 3, 4, 5, 6, 7. There are 7 sides. When I do that division, I don't know where a calculator is. Here it is. 360 divided by 7, I get 51.4. Again, don't worry about it. Sometimes you will get a decimal. That is perfectly acceptable. This is how this works. Now, we're going to move on to goal 2, which is just working out real life geometry problems. And I am going to let you pause the video for a second. Go ahead and read the little blurb before the solution, and then restart the video. Okay, we are dealing with a home plate for softball. Here's what we know. There's 5 angles. This is a pentagon. 3 of them are 90 degrees. They're right angles, so I know they're 90 degrees. The other 2 that don't have a measurement are congruent, and that's what the problem tells us. And then it says, what is the measure of each angle? Well, let's start with the saying that we know that A is 90. We know that B is 90. We do not know what C is. We know that D is 90. And we don't know what E is, but we know C and E are the exact same value because they're congruent. So if C is X, then E will be X. Okay, sum of angles in any pentagon, n minus 2 times 180. So my sum is going to be 5 minus 2 times 180, or 3 times 180, which gives me 540. Here's what I know. When I add all of them together, I'm getting 540. Why? Because the theorem 11.1 says the sum of angles in any pentagon is going to be the number of sides or angles minus 2, all of that times by 180. So let's go ahead and add. Here's what I know. A plus B plus C plus D and plus E needs to be 540. But I know some values. 90 plus 90 plus X plus 90 plus X needs to be 540. C and E are X because they're congruent. If one is X, the other one is X. I get 270 plus 2X equals 540. 2X equals 270. X equals 135. Now, this is the trick question because you need to make sure that you say C is 135 and E is 135 because the final answer is please find the measure of each angle. And now we have them all down here. We have not worked example 5 because we don't need to. So this is about everything that we have learned in 11.1. Now you're not done and we're not done with this chapter yet. I'm going to have you pause the video, stay on page 665, and go ahead and work 3, 4, and 5. So you're going to do 3, 4, and 5. Once you are done with working these, go ahead and restart the video when I tell you, and then I will have them on the board and I'm going to make sure, and you're going to make sure you have the right answers. So 3, 4, 5, go ahead, pause, come back and see the answers. Okay, here we go. 3. First you had to find the sum of all the angles, which was 540. 3 times 180, 540. Then you minus all of the angles that you know, which leaves you with the last angle, which is X equals 95. For 4, that was a regular polygon. That means once you find the sum of them, all you have to do is divide by how many sides or how many angles you have. That was a hexagon, so it's going to be 720 divided by 6, and we get 120. And for 5, again, we're looking for the exterior angle. That is a regular polygon. I'm going to do 360 divided by how many sides or how many angles. There are 8 angles. 360 divided by 8, 45 degrees. If you did not get something right, pause the video again, look at this and see what's missing. And if you got it all right, we are ready to move to 11.2. Okay, 11.2 deals with area of regular polygons. And while this lesson might sound a little bit confusing, it's not. And I'm going to take my time. We're only 17 minutes into this video. And we're going to go slowly and see how we work these because they're not that hard. Your first formula from 11.2, oh, before I forget. I have told the class that I have on Tuesday, I'm telling you the same thing. I encourage you start a cheat sheet again. Put the previous formulas for 11.1 on the cheat sheet. I would put these 2 on the cheat sheet. This is a sheet that you are going to be allowed to use for your test in chapter 11, okay? So stay with your cheat sheets, work them, and keep them close by. The first formula is dealing with the area of an equilateral triangle. Up until right this moment, we always knew that the area of a triangle is going to be half times base times height. That's just what we knew. The trouble is when you have, like in example 1, a regular, we're actually moving directly to example 2. I didn't mean example 1 because example 1 is a proof. You have an equilateral triangle, and all you know about this triangle is that each side is 8. Okay? You do not have the height. To find that height, that's a lot of work. That is because you do know that's a 90 degree right here, which means you're going to have to remember this is a 60 degree. That's a 90 degree, which makes this a 30 degree, which makes this a 30, 60, 90 triangle, which means this little side right here is going to be half of 8, which makes it 4, which means the actual height or the longer leg of this right triangle is going to be 4 square root of 3. And at this point, that would just mean that you remember everything from chapter 9, your vagrant and special right triangles. So this is a hard way to solve this. And now I can go ahead and do the area. But what if I just use the formula they already gave me? For the area of an equilateral triangle, as long as you know the sides, the answer would be 1/4 times square root of 3 times the side to the second power. Let's check it. We're going to check both of these. We're going to stay with this first, and we're going to say the area is half times my base. My base is 8. This is an equilateral triangle. Times my height, which is 4 square root of 3, sorry. So I can do this and this. This gives me a 4. The area becomes 16 square root of 3. This is using this formula, assuming we remember this is a height. This makes a 30, 60, 90 triangle. We calculate the height using the 30, 60, 90 rules and get there. Well, what if we don't know anything of this? We don't remember. And the only thing we know is that this is an equilateral triangle with the side 8. And I have a cheat sheet because Miha said I could have a cheat sheet and tells me that formula. Well, that means my area becomes 1/4 times the square root of 3 times my side, which is 8 to the second power, or 1/4 times square root of 3 times 64. And if you reduce 4 and 64, you're going to end up with 16 square root of 3. It's the same area. So I'm just saying, using this formula on the cheat sheet will actually save you in your test, other than trying to figure out all of this trigonometric and right triangle things, okay? Now, you can leave it here, or if you put all of that in a calculator, apparently it's about 27.7. I will take that too, okay, if you just do it in a calculator. Which brings us to the big part of today. And this is really what we're going to work on the longest. And this is the area of any regular polygon. I already wrote the formula right here. The area of every regular polygon is going to be half times A, which stands for apothem. And you're going to be like, what's an apothem? We're getting there. Times the perimeter of that polygon. Okay, so depending on how many sides it has, you add all the sides as the perimeter. Let's look at example 3. We're not even going to go through the whole explanation because I think it's going to confuse you more. And I'm going to show you what an apothem is by actually working a problem. We're going to go ahead and work example 3. Here's what we know. Remember, we are working with regular polygons. A regular pentagon is inscribed in a circle with a radius of 1. So I have a pentagon that's definitely not going to be regular the way I draw it, but I'm really working on it as much as I can. And then this polygon is inscribed in a circle. Why is this important? You'll understand in a second. And that circle has a ray that it's equal to 1. The ray of that circle is 1. And it's saying, go ahead and find the area of this polygon, of the pentagon. That's what we're looking for. Well, here's what we know. If this is 1 and this is 1, I know the sides of them. I need the apothem. I'm going to use a different color. Let's see if you can see this blue. The apothem is actually the same thing for height in this triangle that we created right here. This is your apothem. It comes down and it forms a 90-degree angle, okay? That's where you are. Now, why is this important? Did I miss one part of the... I did not miss a part of the thing, but I will have to figure this one out to explain it to you. Why is that part important? Because we are going to work with this right triangle and find that apothem that is missing. But in order to do this, I need to know how much is this angle right here, this central angle. This is called a central angle. Well, in order to find that central angle, I need to figure out how many central angles are in a polygon. Because I know the whole circle is 360, but how many do I have in a pentagon, not polygon, in a pentagon? Well, there's a 1, 2, 3, 4, 5. Had this been a regular pentagon the way I drew it, all 3 would be equal to each other. It's good to know that depending on the name of your polygon, that's how many central angles you'll have. If it's a pentagon, you'll have 5 central angles. If it's a hexagon, you'll have 6. If it's an octagon, you'll have 8. If it's a dodecagon, you'll have 12. And I don't know the name of any other things. But depending on how many sides you have, that's exactly how many central angles you're also going to have, okay? So in order to find that particular angle, all I need to do is 360 divided by how many central angles I have. In my case, it's a pentagon, 5, which gives me 72 degrees. That central angle is 72 degrees. Why does that matter? Because this apothem that comes down right here also splits that angle in two. This is an isosceles triangle. This is a side of one. That is a side of one. We have two equal sides, which makes this an isosceles triangle, which means my height, it's also my angle bisector, which means this little angle right here, this one, just half of it, it's going to be 72 divided by 2, or 36 degrees. Now that I have that angle, I can go ahead and find my apothem. I'm looking at this triangle. I'm going to redraw it right here big so you can actually see what we're looking at. Here it comes. I pull it out. I know this is 1. I know this is 90 degrees. I know this is 36 degrees. I'm looking for x. So as I look at this, I go, okay, trigonometric functions. If I place myself here, what sides do I know? Well, I know my adjacent, my hypotenuse, and my adjacent. That is cosine. Remember SOHCAHTOA? Cosine. So I'm going to go cosine of 36 degrees equals my adjacent, x, over my hypotenuse 1. Basically, x, it's cosine of 36. And the trick with this, which I worked it with the class before you, and I was so confused, is to go ahead and keep 4 decimals when you do this all the time. So I'm going to do cosine of 36, and this gives me 0.8090. And that is my apothem. I have my apothem. My apothem, I'm going to write it right here. It's 0.8090. Here's what I'm missing. I need the perimeter of the polygon, but what do I not know? I don't know the side. The base of the triangle, I don't know it. But that's okay, because I can use the exact same angle, the exact same trigonometric, not same trigonometric function, but the same trigonometric process to find now my opposite. I'm not going to name it y. I need this little piece from here to here. And I can do this. This becomes the opposite. I have the hypotenuse. This becomes sine of 36 degrees. It's going to be y over 1 because that's my hypotenuse, which means y is, again, sine of 36 times 1, but I'm not timing it anymore because I don't need to. I'm going to do sine of 36. This is going to give me 0.5878. I need 4 decimals. Remember, we talked about in chapter 9 when we did trigonometry, we'll always, when you do sine, cosine, tangent, keep 4 decimals. And I'm looking at this, and I just found out from here to here. But because this is an isosceles triangle, the distance from here to here, it's equal to the distance from here to here. So at this point, I have found the entire side to be 2 times 5878, or I'm going to go ahead and do that, times 2, 1.1756. 1.1756. I now have the side of this regular pentagon. I can go 1.1756 times 5. That's my perimeter, right? And the perimeter ends up being 5.878. To stop for a second and review what we just did, we use trigonometric functions in this little triangle right here to find my adjacent based on this angle and to find my opposite based on the same angle. Once I found my opposite, because this is an isosceles triangle, I can double it to find my whole base. Going back to chapter 4 or 5 when we did triangles, we talked about the isosceles triangle having the height being also the angle bisector, being also the median, which means it splits this in half. Now that I have my side, I can times it by 5 to find my perimeter. Now I have my apothem, I have my perimeter. I can go ahead and put everything in and get my area. This becomes A equals 1/2 times 0.8090 times times 5.878. And God help us all, this is all calculator work. This is nothing by hand. I'm going to do 0.5 times 0.8090 times 5.878, and I end up with 2.38 roughly. 2.38 is 2.377651. I can go ahead and round to do decimals now. When we deal with trigonometric functions, we're going to keep 4 decimals. Once we move to the area, we can go right back to 2 decimals. So how did we do this? First of all, we had to single out one triangle. We knew the sides of that triangle because they were the radius of the circle. I pulled the triangle out. I needed to find out the central angle. And I actually have a list of rules how to do this that I'm going to add as a material to this video. I had to find out what is my central angle, which is from here to here. How do I do this? I do it by going 360 divided by how many sides or angles does my regular polygon have. This was a pentagon that was divided by 5. I ended up with 72. To find this little angle inside of my triangle, all I had to do is remember that the height of that triangle is also the bisector of that triangle. I took 72 divided by 2, and this little side angle right here became 36 degrees. Once I was able to single out this angle, I was able then to use cosine to find my adjacent, and I was able to use sine to find my opposite. Once I found my opposite, I had to double it in order to find the entire side of this polygon. Once having the side, all I had to do is times it by 5 because it's a pentagon, and I got my perimeter. And all I had to do then is get both of the values, apply them into my area, and find the result. We have one more problem just like that, so don't panic. We'll do one more just for you to see how this works. Let's look at example 4. There's about a pendulum, and it's a dodecadon. That means it has 12 sides. All we need to do in this case is isolate that small triangle that they give us. You see that triangle that they tell us? You have S right here, you have an A, and you have the B. They did not draw this line for A. It's your job to do it, but this is a happy case, and here's why. They give us AB that says that the side of all that dodecadon is 4.3. So I know how much this is. They also give me the sides of the isosceles triangle, and it is 8.3 and 8.3. So this is a much easier problem. Why? Because once I have the side of the dodecadon, I can very easily now find the perimeter. This is gone now. Okay, the perimeter is going to be just 4.3 times 12 because it's a dodecadon. That is 51.6. I love problems when they give us the side of the polygon because it's much easier. Now, the epithem, we have to work it out. And there's 2 ways to do it. You can either do it by following the steps we did, which means you're going to bring down your height or your epithem. Here's your right angle. You can go ahead and find the central angle first. It's going to be 360 divided by 12, which is going to be 30 degrees. I only need half of it. This is the little one that I need, which means that little angle is going to be 30 divided by 2, or 15 degrees. And now I can go ahead and find x, find my adjacent. I can go cosine of 15. It's going to be my adjacent x over 8.3, which means x equals 8.3 times cosine of 15. I get that in my calculator. I get 8.3 times cosine of 15. Let's close the parenthesis. And it becomes 8.0172. There's my epithem. 8.0172. I now have everything I need to solve this problem. My area becomes half times 8.0172 times 51.6. Clearly, calculator work, not a debate about this. 0.5 times 8.0172 times 51.6. I got an error in here. 0.5 times 8.0172 times 51.6. 206 point. Why? Cosine 72. Is my perimeter 51.6? Okay, mine ended up being 206.8. The book says 206.4, and I'm a little bit confused about that. Oh, I know why. Because the book rounded here completely and made it 8. That's the difference. Because this was 0, 1, and so this becomes just 8. I used it as a decimal, and so I ended up with 206.8, but it's 206.4. However, here's why the book rounded up. I wanted to show you that you can stay consistent with the rules that we have followed, because I gave you a list of rules that's attached to this video. However, in this particular problem, because we had both all of the sides that we needed, the book is solving it differently, which gives you the option to choose which way you want to solve when you have all of the measurements necessary. In this case, we pulled the apothem down, and the book says this. Again, this is an isosceles triangle, which means this is a median also, which means this is actually 2.15, and this is 2.15. Right? It split it in half. And because that's a right angle, I can do the Pythagorean theorem. My legs are x and 2.15. My hypotenuse is 8.3. I can do x squared plus 2.15 squared needs to equal 8.3 squared. This is a lot of math, but we'll do it to see if we can get to the same result. Let me clear. 2.15 squared is 4.6225 equals 8.3 squared. No, 8.68.89. I'm going to minus 4.6225. I end up with x squared equals 64.2675. And then I'm going to go second square root of that number. I end up with x equals 8.0172, believe it or not, or 8, because you're going to round up. Now that I know that my apothem is 8, I can go back and go a equals half times 8 times 51.6, because that stays the same, and you're going to end up with 206.4. So when you have all of the information, it might be easier to use the Pythagorean theorem to find your apothem. If you just want to stay consistent and follow the rules that I already assigned to you, then I would say, remember, this is going to be 30 degrees. Why? It's going to be 360 divided by 12 sides. Then we're going to half that again to 15. And then we're going to go through the process of finding cosine of x of the angle to find our adjacent. And that's how we solve it. Okay, this is all we did in class. But before we do anything, you are going to have to work something for me. So I'm going to let you go to 672, and I'm going to let you work 7 and 8. 7 pulls from the lesson we just did in 11.1. It's just asking you to find the measurement of each regular angle. 8 is asking you to find, again, the apothem, the radius, and the area of that side. Please make sure that you read what is said in bold letters, because that's the part of your problem before you start to solve it, okay? Pause and come back. Okay, the end of our video. Let's look at problem 7. What is the measure of each central angle? We said to find the central angle, all you have to do is do 360 divided by how many sides do you have? That's an octagon. 360 divided by 8, 45. And this would be 7. I should have separated them. For 8, it says find the apothem, the radius, and the area. This was actually a pretty easy problem. And if it took you too long to solve it, you got lost in details. And here's why. They tell you in that bold lettering that I told you to read that the height, which means from here all the way to here, was supposed to go through here, is 24, which means half of that height from the center to the bottom is going to be 24 divided by 2. That's your apothem. It's just 24 divided by 2, which is 12. The one thing that we are missing is x, the radius. But we do know, because this is, again, an isosceles triangle every single time, that this little side becomes 5. The other one is 5. So now I have a right triangle with two legs of 5 and 13. 2 ways to solve this. You either know the Pythagorean triplets, 5, 12, 13. You're done. The radius is 13. If not, you're just going to do the Pythagorean theorem. 5 squared plus 12 squared should equal your hypotenuse, or x squared. 69 is x squared, x is 13. So Pythagorean pairs a lot faster to work with. 5, 12, 13, one of them. Once I have the apothem, and the problem already tells me the perimeter of the octagon is 80, I can go ahead and apply the formula on the area. My area is half times 12 times 80, which is 480. This is your final answer. You have homework assigned for this. Don't panic. Please try to do it all. Please try to find the steps that I attached to this video and go one by one and see if you can manage to do it. And if not, we'll work on it again in class. I look forward to seeing you Wednesday. I really did miss you this past Wednesday. And so we'll go from there. And I'll have your tests back corrected to you and all is good in the world. I love you. Happy Sunday.